of the things that we're really interested in is how is it that people can come up with new ideas? And in particular, how can you do that repeatably? And if you think about what it means to come up with new ideas, there's lots of ways that that could happen. So one would be just to stumble on a good idea. And there's lots of examples in the history of science where someone has stumbled on something that turned out to be really important, like when in the discovery of X-rays. That was something that happened just purely serendipitously. Another thing that can happen is pure research and development. So we have lots of companies that spend a lot of time really doing research projects, trying to come up with new knowledge. And that's a great process, but it's also one that's extremely time-consuming. The thing that we've been focusing on is the question of how might you draw your knowledge from one domain to help you to solve a problem in another domain. And that's really the process of doing analogy or analogical reasoning. And that's a powerful and repeatable way of generating new ideas. So what we do is we take students in mechanical engineering who know quite a bit about their domain of expertise, about how to design products. And then what we do is we give them ways to encourage them to draw knowledge from one area when trying to solve a problem in another. So, for example, you might have somebody who's trying to figure out how you might develop a set of weights that you could lift when you're on the road. So if you've ever traveled, you know it might be nice to work out. Not every hotel that you go to has a workout facility. So what you might want to do is to have a set of weights that you could travel with. The problem with traveling with weights, though, is they're bulky and they're heavy, and with all the baggage restrictions, you wouldn't want to be trying to lift 50 pounds of weights to stick them in the overhead compartment. So you'd love to have something that would enable you to travel with weights, and we set that as a problem for people. Now, what happens there? Initially, people get stuck because they don't really know anything that's going to solve this problem. And we encourage them to think about other domains, like, say, an air mattress. So an air mattress has an interesting set of characteristics. It would be very bulky to travel with a mattress, but if you could put the cushioning in the mattress only at the point where you needed it, then that would be really effective, and that's what an air mattress does. Normally it has nothing in it. You can put it away and store it and travel with it easily, and then at the point of use you can fill it with air and make it comfortable. And with weights you can do the same sort of thing. You can have weights that normally don't have the weight in them, but then you fill them with something easily available at the point of use, namely water in a hotel room, and then use that to work out. And so what we did was we gave people strategies for helping them to think about problems in a more abstract way, to think about these relationships like using the key bit at the point of use rather than having it there all the time. And those kinds of strategies then helped people to recognize that they actually did know about other products that might help them to do these designs in the future. And that made their designs a lot more effective and made more groups of people better able to solve these problems.